Hello, everyone, and welcome to Groovy Duke, your channel for all things groovy-lang. If you find any of these videos useful, don't forget to like, comment, subscribe, and share so more people can have a groovy day. So today we're going to be talking about using lists within Groovy. So I'm just going to take myself off the screen. We're going to go down to our Groovy console, and I am going to copy over some Java examples, and we're going to see how this converts to Groovy, which is a little less verbose and easier to use. So for this example, I'm just going to be using array lists. I'm not going to be getting into linked lists. There are reasons why you'd want to use one or the other, but for this example, we're going to keep it simple just with array lists. So right here, you'll see that we're creating a list for hardware, and this is a list of strings, and we're using the new array list of strings. So that's pretty standard, fairly verbose Java way of creating a new list that you can put things into. And then to add things, we have to do hardware.add, hardware.add, all these like add statements. There is another way to do this using arrays, which kind of came in later, but it's kind of a an odd way to do it. But this is the traditional way that you would do things within Java. So after that, what you might want to do is you might want to get the last item in the list. So, hardware.get, and you give it an index. And for this, these are zero based. So we're doing get size -1, and that will get us the last element in the list. We also have a for loop here, just to say you wanted to iterate through all of them and then print out the index next to it. So we'll do index +1, and it's just your traditional older style Java for loop for if you want to have that index. We can also do sorting. Um, there is a sort method on the list class or list interface, I should say, but it takes a comparator other rather than you just being able to sort like you can in Groovy, which I'll show you later. So this was one of the ways I did it at one point. There's probably a better way at this point to do this, but just to give you an idea of what we did at one point, you could do a to array and then use arrays.sort items to get like a sorted list, and then you could iterate over those items and print them out. This is one of the, well, it was newer as of Java 5, which is actually pretty old at this point, but one of the ways that we used to use for iterating over lists. We also, you have streams now and things like that, which came in Java 8, but this was one of the ways that we used to do that. So let's see. Another thing to show you, I don't think that Java does have a join method like Python does, but Groovy does and has ripped it off, which is very nice to use. Because if you've ever had to do this in Java, where it's like, all right, I want to print out a list of items, and basically I want to have them comma separated. And it's like if you do a traditional for loop without dealing with the edge case, you'll end up with a comma at the end because you'll just print out the thing, whatever index and the comma after it. So for this, in order to get around it, I print out the first item, and then for each additional item, I print out the comma and then the item. So let's just run all these, just so I can show that they all run fine. And basically, there's your last item, iterating over the list, having the list sorted, and then here's the list with it being comma separated without having the extra one at the end. So if we go over to some Groovy code, let me get the Groovy code, copy that. I can show you how it is a little bit less verbose, and I would say a little bit easier to read. So here we can create the list. I'm still using the type here. I particularly like to use types with Groovy just because it makes it a little bit more self-documenting, and basically if I ever want to statically compile it, I don't have to deal with some of the edge cases with that. But you could just use like def here if you were doing like something scripting, or you're just doing a quick example. Now, in this case, you'll see I have an open bracket and a closed bracket. This denotes that this is a list. So if I wanted to do just, say, an empty list, I could have something like this where I have open bracket, closed bracket. But in this case, I'm actually initializing a whole bunch of strings within that list. Kind of like how you might see something within, say, JavaScript, where you can do inline lists and maps. We'll get into maps in the next video. So also we have this left shift operator, which allows us to add things to a list. So we have our hardware list, and we add the screwdriver, and then here we're printing out the last item in the list. And what Groovy has is it has this also has this square bracket notation where you can give it an index and it'll get that index of that list. So this is equivalent to writing out dot get whatever index you want of that list. Now, one interesting thing that this does is it can also take negative numbers, and this -1 would be the last item of the list, and you could actually go back, even further if you wanted. I've never had any use for anything going back further, but going from like getting the last item of the list sometimes is useful. Okay, we also have these next few, which are going to actually start to deal with closures. I'm not going to go too deep into closures because I have a whole video on closures. But a closure is similar to a Java Lambda. It's essentially like an anonymous class function that you can call. So with this particular method, this is the dot each with index. You'll see this open bracket, close bracket. This is equivalent actually to if I put parentheses around it, and this like between the brackets is a closure, but you don't have to put the parentheses. So there are some places in Groovy where you can drop parentheses, and I'd say you can drop them as long as things still work. There are some edge cases where the compiler will get confused, and putting parentheses back in makes it work, better for certain things. Not with what we're going to be showing here, but it's something I'll probably get into it in a later video. So what this does, this particular method, is it takes this closure and calls it each time with each of the indexes of like the basically the element of it and the index of it, so that you can print out you know basically what we had before. I'll run this just so that I can show it. So with this one, as you can see, it is still zero index. So if I wanted this to actually be the same, what I could do is come in here and add squiggly brackets along this and do +1. Another thing with the string interpolation, I don't know if I remember if I got into this, is the squiggly brackets are optional unless you're doing, like, say, an operation or calling a method, or if you want to put like a period or something past it. So just something to keep in mind. So we'll rerun that, and you can see now the indexes are 1, 2, 3, 4, 5. That would be something that you probably do to make it quote unquote human readable, because most people think of starting to count at 1 instead of 0, but zero based indexing is how we do it within the computer world for the most part. Something else that we can do is obviously sorting. So for this, what I did was I took the hardware list, I did a clone. The reason I did a clone was because the dot sort method is destructive, so it will actually change the order of things. So doing a clone makes a new version of that list. And then I did a dot each, which is the same thing as dot each with index, except for it's just going to iterate over, not give you the index. And I'm using the default variable here, which is it, where up here you can see I used a couple of, I set the variables myself, overriding the default one. But this will just print out those sorted items, which, let's see. So you have the list, and then we have the sorted list here, which is, same, but it's, you have the numerics and then, alphabetical order after that. Again, with the last item we have here, which is using the join, which, was completely ripped off from Python, which I'm glad they did, because it's one of those little edge cases that you do a lot where it's like, I just want to join a list together with some type of delimiter, and I don't want to have to deal with, like, that last one edge case. So you can do just list.join, and basically, you add the comma, the delimiter on there, and it'll print it out as you can see down here. Another thing you can use, you can see this star, which is called the spread operator, and this will what this does is it takes a method that you can run on this collection and does it on each of the elements in that list. So what I'm doing is a two uppercase on each of the elements in the list, and then I'm doing a dot join and printing that all out. So I'll just scroll this down a little bit, and you can see here's the result of that. So, they're all uppercased. Let's see. So moving on. Wait a minute. Yeah, there it is. Let's just scroll this down a little bit. Now we have another thing, the method we have on list is the collect, which I would say collect is like map in a lot of different languages. So kind of similar to the spread operator, where you're going to take a collection, you're going to do dot collect, give it a closure, and do something to each element in that closure, and it's going to collect that into a new list. So in this case, I'm taking the list 1, 2, 3. I am going through each of those elements and multiplying it by 2 and collecting that into a new list, which I'm going to print out, which would be 2, 4, 6 right here. So as you can see. We also have inject, which is like, think of this kind of as map reduce. So with this particular instance, what I am doing is I'm going to basically take all of these and which see this one, and I'm going to be using the string as my default case, and this is going to basically take the that string and add the numbers. So when you add a number to a string like this, it ends up being string concatenation. So the result will come out the other end as counting 1, 2, 3, which is equates to true because we're doing the equals equals here. So that's one thing that you could do. But if you wanted to do something like you wanted to like actually add those numbers, you could start with like say a default of 0, and then basically you can take that default, that account, and it would add it to it, and you would eventually end up with the number 6, which is the addition of 1, 2, and 3. Another thing that you have access to is times, which this is something where, say you wanted to run something 5 times, you could do 5 dot times, and basically do whatever it is that you're doing that many times. So and basically when it does that, you get an index, which will be it. So with here, what I did was I did some value equals 5, and I did some value dot times, and print line it, and you see I get 0, 1, 2, 3, 4. So it printed it 4 times with the indexes starting at 0. So that's what I have for list, but I'm going to also include just a little aside of arrays in Groovy, because you can use primitive arrays in Groovy. So I'm going to get rid of all that code, and I have just some examples of using arrays, which arrays are similar to lists. Well, lists are essentially enhanced arrays because you have your array list, and underneath that essentially is an array. But there are some structures that allow it to be able to expand when need be. Arrays, on the other hand, you don't have the ability to expand them, but they tend to be more performant. So if you know exactly the size of something you need, using an array, yield you some performance benefits. So here is one of the traditional things that you can do. You can set a string array, say of Groovy books, and I can just set that as a list, and basically Groovy will do the interpolation for me, as long as I'm not doing static compilation. Which, in case, I think I might have to add something like as string and like that, or do a casting or something like that. And basically you can print out all the books that contain Groovy. So this is just this is another example of something similar to um, dot each, but instead we're using every, which allows you to check to see for basically Boolean operations. So what I'm checking here is that what was it that every book contains Groovy. So this is the check that I'm doing, that every book contains Groovy, and I have two books listed here, and they both have Groovy in the title. So this comes out to be true. So it's kind of similar to like collect, but for Boolean operations, where you want to see that everything of your action that you're trying to look at applies to each of the elements in a list, which can be useful. That's not particularly related to arrays, but we did start with a list that we made into array. Another thing that you're able to do in Groovy 3 Plus is you can use the inline syntax for doing arrays. So here we have an integer array, and we have the squiggly brackets, which normally in Groovy this would older versions, this would be a problem because it would see this as a closure rather than an array. But they made it smarter in Groovy 3 with the new parser that came in with Groovy 3, so that it can now handle that. And you can do the various operations that you would do for arrays, as you can see here. Um, and there's nothing particularly interesting about that code, but as you can see, those all come out to be true if you want to play with and look at this code. So that's all I have for you today. So have a groovy one.